about frequency sampling method. Frequency sampling method. Okay, so what is frequency sampling method? Okay, so we know about sampling. Okay, so by using this frequency sampling method, a set of samples is determined from the desired frequency response and it is identified as the DFT coefficients. Okay, so a set of samples is determined from the desired frequency response and identified as DFT coefficients. Okay, so few steps are involved in designing this frequency sampling method. The first step is we need to find the samples omega k equal to 2 pi k by n. Okay, so in the second method we need to find the sampled frequency response. Sampled frequency response that is given by h gap of k equal to e power minus j theta of k, where theta of k equal to n minus 1 by n into pi k. Okay, so the second step we are finding the sampled frequency response, and the third step the filter coefficients is given by h of n equal to 1 by n into h gap of 0 plus 2 into summation k equal to 1 to n minus 1 by 2 real part of h gap of k into e power j 2 pi n k by n. Okay, so the filter coefficient is identified by using the third step. Okay, so by these three steps we can design a frequency sampling method. Okay, so let's have one example. Let's solve one problem. So the problem is like this: a low pass filter has a desired frequency response hd of e power j omega equal to e power minus j 3 omega for the limit 0 less than or equal to omega less than or equal to pi by 2 0 otherwise for capital N equal to 7. So this is the given parameter. Okay, so in this problem it is asked to find the low pass filter. So we need to find the low pass filter, and the desired frequency response given is hd of e power minus j omega equal to e power minus j 3 omega for the limit 0 to pi by 2. Okay, so considering our steps, what's the first step? We need to find the samples. Okay, so moving to the first step, step 1, we need to find the samples. Okay, so how will you find these samples? We are having a formula omega sum k equal to 2 pi k by capital N. Okay, so given n equal to 7, we need to find omega 0, omega 1, 2 up to omega 6. What is omega 0? How will you find omega 0? 2 into pi k we substitute 0 by capital N, that given value 7, that value will be equal to 0. Then how will you find omega 1? 2 into pi into k here 1 by 7, that is 0. Similarly, omega 2, 2 into pi into 2 by 7, this is, sorry, 0.897. So 2 into pi into 2 by 7, that is 1.79. Similarly, find omega 3. So how will you find omega 3? 2 pi k. What is k? K equal to 3. 3 by capital N, that is 7. So you will get 2.69. Then omega 4, 2 into pi into 4 by 7, that is 3.59. Then find omega 5. Formula 2 into pi into k, k equal to 5 by 7. So you will get 4.487. And omega 6 equal to 2 pi into k, 6 by 7, that is 5.385. So these are all the samples. Okay, so these are all the samples we got from this equation, omega k equal to 2 pi k by n. Okay, so in the given desired frequency response, what's the limit given? So the limit given here is 0 to pi by 2. So 0 to, the limit given is 0 to pi by 2. Okay, so since we are going to design a low pass filter, it will filters the frequency having low frequency than this pi by 2. Okay, so it will pass only the low frequency values. Okay, so what's the value of pi by 2? Pi by 2 equal to 1.57. Okay, so it means it will allow to pass the frequency having less than 1.57. Now we want to compare this cutoff frequency with these samples, whether it will allows the signals or samples or not. Okay, first compare the sample 0. It's having 0. That means it having the lower cutoff frequency. So it will allows. So this sequence will be, the first samples will be allowed by this low pass filter. Then compare the second one, will it allows 0.897. This also lies below these values, so it will allow this value. Then compare the third sample, it won't allow because it exceeds the cutoff frequency, so it won't allow. Similarly, the third one, it won't. Okay, so the remaining things also it won't. Okay, so based on this one, the samples allowed is for k equal to 0 and 1. For this cutoff frequency, to design a low pass filter, it will allows the samples k equal to 0s and 1. Keep this in your mind. Okay, so now we are moving to the second step. What's the second step? Second step, we need to, step 2, we need to find h of k, desired frequency response. For that we need to find theta of k. What is theta of k? It's a formula n minus 1 by n into pi k, that is equal to 7, n equal to 7, 7 minus 1, that is 6 by 7 pi k. And what's the formula for h gap of k? This is the desired frequency response. What's the formula for h gap of k? E power minus j theta k. E power, what's the formula? E power minus j theta of k. Okay, so from this we can write h gap of k equal to e power minus j. We know theta of k equal to 6 by 7 pi k for k equal to zeros and 1s. Why? Because for these values it will allows only k equal to zeros and 1. So we are considering k equal to zeros and 1. 0 otherwise. Okay, so what we are doing is, we are for this low pass filter, we are considering the samples k equal to 0 and 1. Okay, so this is the desired frequency response of the given frequency value for capital N equal to 7. This is the low pass value. So we are having the values k equal to 0 and 1. Now we can move to step 3. What's the step 3? We need to find the filter coefficient. Okay, what's the formula for filter coefficient? H of n equal to 1 by n into h gap of 0 plus 2 into summation k equal to 1 to n minus 1 by 2 real part of h gap of k into e power j 2 pi n k by n. Okay, so this is h of n. So we need to substitute everything here. So what is 1 by n? That is 1 by n equal to 7. So what is h gap of 0? What is h gap of 0? This is nothing but this is h gap of k. This is nothing but this is h gap of k for k equal to 0. For designing this low pass filter, we are having a frequency response for k equal to 0. That is h gap of k. Okay, so what is h gap of k? That is e power minus j 6 by 7 pi for k equal to 0 plus 2 into summation k equal to 1 to n minus 1 by 2, that is 7 minus 1 by 2, 6 minus 1 by 2, that is k equal to 1 to 3 real part of h gap of k. What is h gap of k? Here this is e power minus j 6 by 7 pi k into e power j 2 pi n k by n. Now we need to simplify this one. 1 by 7 into e power 0. What is e power 0? That is 1 plus 2 into, we need to expand this one. Before expand this one, just check once. So we need to evaluate k equal to 1, 2, 3. Okay, so for the given low pass filter, we are having the values for k equal to zeros and ones. For all other values, zeros. That means for k equal to 2, 3, 4, 5 and 6, the value will be equal to zeros. Okay, so what we can do, we want to expand this one. So for the given low pass filter, only for, already we applied for k equal to 0 here. So k equal to 1 only, we are having 2 and 3 automatically goes zeros. Okay, now substitute k equal to 1 here. So 2 into real part of, okay, real part of e power minus j 6 by 7 pi into 1. We are substituting k equal to 1 here into e power j 2 pi n k equal to 1 by n equal to 7. The remaining two values equal to 0. Okay, so now again we need to simplify this. 1 by 7 into 1 plus 2 into real part of, we need to take the common term outside. We can take this e power j 2 pi by 7 as a common. Okay, so I am taking real part of e power j 2 pi by 7 as common. So here one n is there, and here 6, taking 2 out, minus 3. Okay, so this again we need to apply. Okay, so already we know what here we are having one exponential term. What's the formula for e power j theta? That is cos theta plus j sin theta. Here cos theta is the real part and this is the imaginary part. So here we are need to consider only the real part. That means we are going to consider only the cos theta. So this h of n can be rewritten as h of n equal to 1 by 7 into 1 plus 2 into real part of this one. So cos theta. What is theta here? 2 pi by 7 into n minus 3. Okay, so this is the given filter coefficient equation. So here the given capital N equal to 7. So what we need to do? We need to find h of 0, h of 1, h of 2. Okay, how will you find h of 0? By substituting n equal to 0 here. Okay, so by substituting n equal to 0 here, simplify this one using your calculator, you will get 0.11. Okay, similarly we need to find h of 1, h of 2, h of 3, okay, 4, okay, h of 5 and h of 6. Okay, so h of 0 will be equal to minus 0.11. H of 1, how will you get this? By substituting n equal to 1 in this expression, you will get h of 1, that is 0.079, and this one is equal to 0.32, and this is equal to 0.42, and this is equal to 0.32, 0.079 and 0.11. Okay, so these are all the values. Okay, so here we can observe that some values are symmetric. Okay, what are the values symmetric? You can verify this one. H of 0 will be equal to h of 6, and this h of 1 will be equal to this one, that is h of 5, and this h of 2 will be equal to h of 4. Okay, so these values are symmetric to each other, and we are having one individual tag. Okay, so all these values are called as the filter coefficients of the given frequency, desired frequency response.